Ángel, we are live. The stage is yours.
Thanks, Marcos. Hello, everybody. Welcome to this first on-site Cloud Native Asturias. It's a pleasure to be here with all of you. My name is Ángel. I have here my colleague Marcos with me. Hello, Marcos. How are you doing? Not sure if you can hear me now, but okay. Here, Marcos is also with me. Here, Marcos.
All good here. Nice to see you guys. I'm pretty sure this is going to be a great session today. Actually, we are pretty close of our birthday. Actually, we started like 1 year ago, more or less. I'm very, very happy to have this first in-person and in virtual session with all of you. We have 4 amazing speakers, 4 amazing talks. So hope you enjoy it. Thank you, Ángel.
Yeah, thank you, Marcos. Without further ado, I would like to first of all thank Abel, who is here with us today, for giving us the opportunity to host this first event, which we are really proud and glad that it's happening. It's the first one. Let's see how it goes. But thank you very much for the opportunity. We hope to keep these events for a long time. So yeah, thank you very much. That's what I want to say. Without further ado, I would like to run just quickly through several slides that I have, just to what we do usually introduce a little bit the. First of all, welcome everybody. We are part of the CNCF Cloud Native Computing Foundation initiative. It's a chapter, one of the chapters, the chapter from Asturias, and we are happy to, as we said, to have our first on-site event. Contact, please, just the usual stuff. We please respect everybody. We have some of contact here. Just follow. This is where we are right now. We are in Asturias. A chapter from Asturias. We have a couple of speakers from here. Actually, 3 of the speakers are from here. 2 will be here in fact with us. 2 will be another one will be online, and we have a 4th one which is coming all the way from Atlanta. I don't know if you can. Actually, I'm not moving the presentation that I should be moving, so apologies for that. Basically, welcome. Just to reiterate, a lot of contact here where we are in Asturias. Our chapter based on Oviedo, and now we are in Avilés, right there. And we have 3 speakers from Asturias, and we also have 1 other speaker from Atlanta, Georgia, in the US, which will be joining us towards the end of the session. Basically, that captures a little bit the essence of what Cloud Native Asturias is. We would like to bring on board of this Cloud Native CNCF initiative Asturias and Asturias professionals, and also international from the international community as the speaker that we have today. For this event, we have a specific hashtag that we are using, CNADC'21, and we have the usual Cloud Native Asturias. Please follow us in social networks, retweet, like, and just helps us to promote these events, which I think is on the benefit of everybody on the tech community in Asturias and also internationally. We have a pretty packed agenda for today. We'll start with a little bit of some words from Abel about cloud and telco business. We'll continue with José Manuel Redondo about infrastructure as code, means compliance as code, deploying secure machines automatically. We'll have a 10-minute break. Then we'll continue with Andrés about Kubernetes local development presentation of useful tools to develop the Kubernetes locally. And finally, last but not least, we'll have Ravi Lachman talking about infrastructure as code. What about the application introduction, application as code? Basically, we will be wrapping up around 12:30, hopefully, and there will be also obviously questions between sessions. And yeah, we just one last thing, we have called for papers so that everybody that wants to participate in the future, we will have more events. I will say something also at the end, that whoever likes to participate, please reach out to us and send us your proposals. We will be happily reviewing them and then, you know, scheduling for one of the next sessions. And that's pretty much from our side. I don't know, Marcos, if you would like to say anything else. Otherwise, we'll give the stage to Abel. Marcos,
yeah, let's go for it.
Okay, perfect. So Abel, okay, it's all yours. Mike. So, and then let me switch the presentation for you.
It's okay. Can you hear me?
Yes, all good online.
Okay.
Perfect. So just to go ahead.
Vale. Okay.
Yeah, like it. Yes. Right, Abel.
Okay. Thank you. First of all, I would like to thank everybody for coming here today and also to the attendees from internet. For me, well, I'm very happy to be part of this first presential event of Cloud Native Asturias. I think that is a very good opportunity to share our experience and knowledge about the communications business. And well, I'm very proud to represent my colleagues of Satec. And I hope you find what I'm going to tell you and me and the other participants very interesting today. And well, let's start. I prepared some slides and okay, well, what I'm going to tell you today is well, we have some main points here to talk about. The first thing I'm going to do is to present Satec, to tell you what is Satec and what Satec does. And what is Alvatross inside Satec? Alvatross is a product-oriented division inside Satec, and we will see why we created Alvatross and what are the goals and the objectives of Alvatross inside Satec. We are going to talk also about the product that we developed, its characteristics and methodologies and technical solutions that we follow for making our work, and the current projects and past projects that we did, and the future projects that we have in mind that we will do. So, and to finish, I want to tell you about the main telco business standardization organization around the world, which is TMForum. Is very interesting. There are a lot of companies there working in the standardization of this business. And we are going to talk also about the open digital architecture, which is a change of paradigm for all of these standards. And what I'm going to tell you also in what work groups we are participating in TMForum. And to finish about NFP, SDN, and NAS, which is a new paradigm related with networking. So, first of all, what is Satec? Satec is a Spanish international company created in 1988, so we've been operating for more than over 32 years. It's 100% Spanish owned. It's a private company, 100% Spanish, with a turnover of 100 million, more than 100 million, and half of this turnover is related with telecommunication business. Comes from business customers, for telecommunication customers. We are around 1,100 employees in working in many places. In Spain, we have offices. We are placed well, here in Asturias, and we have several offices also in Madrid, and Galicia, also in Vigo, Barcelona, many places. And we have people working in executing projects in several countries, especially in Africa. We did huge, very important projects in Namibia and Angola. We also did things in Saudi Arabia, in Morocco. We have there one of the companies of the group is there, and it's a very important company in telecommunication business. And well, this is where we are. And what we do in Satec, well, we do consulting, we do a lot of things. We do consulting in business processes, in technology, etc. We execute and we do solutions for communication, software management, OSS and BCS, which has a lot to do with what we in Alvatross do. We also offer services of support, cloud, hosting, housing, etc. And also we offer some solutions and some services related with emergent technologies like IoT, big data, analysis, etc. And well, we do this in many different functional areas, in many different business like telecom, government, utilities, transport, health, etc. So this is Satec. And well, what is Alvatross? Alvatross is a division of Satec. And well, it's a story started at 2015. At that time, Satec won a huge project in Angola. It was the transformation, total transformation of the digital system of the main fixed line operator in Angola, which name is Angola Telecom. It was a 4 years project, a lot of work, and we did a lot of things there, and some of those things were related with OSS. OSS is the operation support system of a telco operator, and in that area, what we did is what we developed was products for order management, activation engine, and resource intention. And well, when we finished this product, we realized that we had very valuable products, and that those products might be sold and reused in other companies, in other telco companies. And meanwhile, we started receiving a lot of requests from other companies around the world asking for that and requesting more products and more solutions. So the need to convert this what we did in this project in product raised, and for that reason we create Alvatross, which is basically a department with very specialized in telco business inside Satec, and very focused on product and product management and product development. After that, what we did is to rebuild, to improve, to make new functions, new things, and package all of that software in independent products. And well, we did a lot of improvements, and after that we won another project, a huge project also in Namibia for the main mobile operator in the country, and it was a very good opportunity to be there with our products and to test them and to improve them again and to build more features. And well, we've just gone live 2 months ago, and we are very happy because they are working very well, and the customer is very happy, and well, we have a very good products. And now, well, we continue working on these improvements. We continue aligning our products to the main standards of the industry, and we are on this. What are our products? Those are the main products that we have. We have more, but these are the more important. We have the main piece of the core of the solution is the order management. This is used actually, the main problem that we solve with that product is this. What we do is we connect or we talk with the business side of the telco operator. We make and we try what we try to do is complex to explain this in English. But basically, what we try to do is to get customer requests expressed in the language of the customer, expressed in the marketing language, business language, and we convert this in real services in the network, talking with network elements to software and to different inventories, etc. I think that is better to explain with an example. A customer wants to get a bundle with a pixel line, maybe a couple of mobile lines and TV, for instance. And what we do is to get this request, and we orchestrate and we manage this request to make this real for the customer, to give the customer the services working. Okay, but this is what we do, and all of those things are aligned with TMForum, which is the main standardization organization in the industry, and all of them also talk with each other through OpenAPIs. Are standardized and well-defined OpenAPIs that allows to talk between our own products, but also with third parties, with other components of the software system in the operator. Okay, what are the key characteristics and benefits of our solution? Our solution is catalog-driven. That means that we have to control the behavior of this software management through a catalog configuration. There is a place where you can configure products, services, resources, make relationships, and this will drive the execution of the orders. So local is at the end the goal that we want to get with this. Everything is automated unless the operator can do any kind of manual intervention. All that process can be totally automatic. Well, we have also the ability to create workflows, to manage some behavior or some logic. Again, low code or based on BPMN standards. We can deal with legacy systems and industry standard compliance systems inside the operator, so we can integrate with almost everything. Well, our solution is stability and cloud native, very important and ready for the future, and no vendor locking. That again, we can deal with any kind of vendor, any brand, Huawei, Nokia, whatever. We are not restricted to any vendor. About methodologies, well, the methodologies we follow for the development and the deploying of our products is DevOps for continuous integration and deploying. And for development, we use Scrum. We use agile methodologies. We usually use a few sprints of 2 weeks. We are continuously doing new things, new features, and it's an interactive thing that we are doing. About the technical solution or technical stack, we are following a microservice architecture. All of that we do is cloud native, and it's ready to be deployed in public and private clouds, and also on-premise. We are the database agnostic. After MariaDB, well, actually we support 6 or 7 different databases. And well, we are very focused also in using this. We have a team dedicated to this, and our user, you pay much attention of our user interfaces. And well, this is the technologies that we use. Almost everything is based on Java, the framework like Sprint. In terms of infrastructure, our solution is based on Docker and Kubernetes clusters, etc. Well, for architecture, in terms of functional architecture, is what we consider. We have the management, who talks with the BCS side of the operations system, receiving requests from customers based on a catalog. This order management system is able to decompose and to execute the actions needed to provide the services or the products that the customer is requesting. We have a piece of cloud management. If something is wrong here in this execution of orders, we can deal with that through these components. We update service inventories, resource inventories in the meantime, and we have also a piece named application engine, which is like a wrapper of the complexity of the network. This component, what does is to talk with physical networks, talking it's ad hoc or implementing ad hoc protocols in much cases. And it's at the end upstream. It provides a generic interface, regardless the network elements that are downstream. And well, the GIS is just a representation in a map, a geographical representation of the inventories, where you can see the antennas and things like that. I don't know how to explain well. Let me know if I'm running out of time.
No.
Just it's fine. Well, what products, what projects we executed until now? As I said, we executed a huge project in Angola. It's Angola Telecom. We just finished the MTC project with the main mobile operator in Namibia, and now we are executing a couple of projects with Abel. So we have a lot of experience in the African market, but not so much in the European market. The African market has some restrictions, some things different from the European market in terms of infrastructure availability, bandwidths are lower than what we have, and also cultural and political differences that sometimes are conditioners to what we do. Like, for instance, I don't know, we can't go with software as a service model here for our products because in general they don't want that its data information is deployed or is owned by an American company like Google or Amazon or whatever. So they prefer to have everything at home, on premise. And well, we are very looking forward to have the opportunity to execute projects in Europe to explore these business models and these kind of things. And well, the opportunities that we have currently, most likely is this one is again in Namibia. In this case, is the main fixed line operator in the country, but we have also things in Africa, in Namibia, in Asturias, or Jipa, Mali, etc. We have a lot of opportunities. We are always doing demos, presentations to a lot of companies all over the world. Okay, this is about Alvatross and what we need. Do you have any questions? If you have any questions, just let me know. Okay, now I'm going to talk about that thing that is a very interesting thing, because it's a standardization organization where what is trying to standardize all of the information systems that telco operator and more in general digital service provider should do in terms of information systems. We are participating, I think, more than 850 companies there, working together, trying to define these standards, and we can find service providers like Orange, like Vodafone, like Telefonica, etc. Technology suppliers like Nokia, etc. We have also consultancies like Accenture, Capgemini, and system integrators like us. So very important companies all over the world working here together to define standards for the telecom industry. And well, those are the things that TMForum defines and standardizes. First of all, what we have is a standards of what we identify are business processes and activities. So, TMForum have a set of business processes that CSP should implement and some activities that has to be performed in these business processes. They call it EDOM, Business Process Framework, and an example of this is the order management. The order management is a business process where different components of different information systems are involved. Billing, for instance, to billing customers or something like that is another example of business process. We standardize also the information structure or the data model, the information model. They call it C, the information system, and it's about to identify business entities, which attributes those business entities have, and the relationships between different business entities. Examples of this are resources, are customers, are invoices, I don't know, any kind of business entity that is in our operator. And finally, it's the application framework, the TAM, which tries to define and identify functions, applications and functions. Applications is something that is going to be dedicated in the standard actually. And at the end are functionalities like, I don't know, create a customer to build I don't know, update a service, something like that. Very much in specific functionalities that the software should provide. And around all of this are the OpenAPIs, which is REST-based OpenAPIs, using for the interchange of information between all of the software pieces that are part they are over the sea, and they are continuously changing that APIs and creating new APIs. Well, and this is the traditional view of TMForum. But something is changing in TMForum in general, and they are moving to a new paradigm that's named Open and Digital Architecture, ODI. And this is a blueprint for modular, cloud-based, and of an open digital platform that can be orchestrated using artificial intelligence. So this is about to identify and define components, software components that provides that are cloud native, can be deployed in a cloud infrastructure, and that are organized into a loosely coupled domains. Those components provide open APIs, can implement some functions, and can be part of some business processes, and can own or use several business entities. So, sorry. Sí, one moment. No sé qué pasa. Okay, so the idea of this is to take the assets of the other frameworks that we saw in the previous slide and build these components, this set of components. And this is to provide zero-touch interoperability, to be plug and play, to go to a cloud infrastructure and put this component there, and those components will discover one each other and connect each other, and using AI algorithms, we will achieve to don't have any manual intervention for this. Let's see. This is just a summary of what I've just said. We are moving for a traditional stack where we have an operations layer with processes and people. We have a BCS layer, business support system for customers billing, all that has to do with the business. We have an operations support system layer related with all the operations that we have to do to provide the products to the customers and to deal with the network physical architecture. And we are moving to this other paradigm when we have autonomous infrastructures. We have cloud native components that are reusable, plug and play, and microservices oriented. And we have a layer for operation that is AI enabled and real time and automatic, and with very few manual intervention at the end. And this allows zero-touch interoperability between all of these things, and zero-touch partnering with other partners. Because, well, it's very common now that some CSPs or telco provider gets or uses part of the infrastructure of the services that others. There are a rent of services and physical infrastructure between telco providers. And what we do inside TMForum, we are participating actively in TMForum. All of our products are aligned with these standards, aligned with SID, with heterogeneously, with TAM, and we use OpenAPIs. And in fact, we have certified some of the APIs that we use. We are participating in the definition of two of those components. We are specifying the service order management component and the resource inventory component together with people from Orange and other companies. We signed the OpenAPI and ODA manifesto, so we have a commitment with them to follow all of those standards and to be involved in this. And we are in the top 5 of system integrator with OpenAPI certified. We also are participating in another two work groups, which are LACA and the IG-1228. I will talk about that in the next slide more indeed. And we also have a policy of certification internally for workers, for people. There are more than 55 people certified and many different certifications. 5 minutes. Okay. In many different certifications of TMForum. I think that the first thing that we do there, we are participating in TMForum, is in the definition of the service order management and resource inventory management, and this is how to identify ITOM processes and activities on which the component is involved. It's about to identify business entities that the component owns and uses. This is also about to identify functions that the component has to implement, open APIs that it uses and it provides, and it's also about to define, to create some YAML files for the definition and implementation of the components. And this is linked with the use cases that we have in the IG-1228. And well, as a result of this work, there are some notebooks about modify and create new assets in the standard. For instance, we can realize during this exercise of defining this component, we can realize that we need a new API, or we need to modify something, or a new attribute to a business entity, something like that. It's a continuous feedback. All the assets of the standards is continuously feedback with the group with the work of the groups. Is what I'm trying to say. It's an interactive work. Well, the IG-1228, the other initiative where we have, is about to describe real use cases where these components are used and talk one each other with OpenAPIs. What we do here, we have one already published. It's a use case about service and resource order management for postpaid mobile subscribers, and we are working on a product management use case. What we do here is to explain the scope of the use case. We identify the business entities involved in the life cycle. We describe also the user interface if it's needed. We also do the catalog configuration needed to execute that use case, and we do some scenario diagrams to describe the behavior, the different components inside the use. And well, to finish, the other initiative what we have is the LACA, which is it's a proof of concept of this architecture and this architecture and this new paradigm. What we have here is some companies that, including us, we are providing real software, commercial software, to be wrapped as another component, and we deploy this in a campus, in fact, it's a Kubernetes cluster, to test of things, to connect things together, and to improve this. And this work also feedbacks the other work groups, and so on. Well, at the end, I think that this is very interesting. For me, it's incredible to see that so many companies with so many people, with so many different points of views, works together to and agreed to define this kind of things. It's a very interesting thing to see how that works. And well, very quick to finish, new stuff in network business. There are three things that is raising the last time, and are new paradigms to move the networks through open software and network infrastructure. So we have network virtualization functions that are about to virtualize network function and deploy them into general purpose hardware. Is to convert actually the physical things, the physical network, in something that's in software that we can deploy in computers. We have also the software-defined networking that makes networks programmable and separating the control and data planes. And at the end, is about to create a software layer to manage networks. And using these technologies, there is a new business paradigm, which is network as a service, that is a cloud service model which customers can rent network services to other customers. When I say customers, I mean digital service provider, renting network services and network capabilities one with each other. And well, that's it for me. Thank you very much. I don't know if you have any question. I'm happy to answer it.
Yeah. Also in the Africa area that you mentioned that there are some issues there. Is that thing a cultural thing that they don't want to work with US and other countries, or is also like a legal thing because they don't have regions in every place in Africa, so the data needs to stay in the country, etc.
I think it's both. It's something. I mean, maybe not cultural, but they don't have the degree of they don't have in the point that we have in terms of technology in Europe.
Yeah.
And also it's a political stuff, I think. Depending on the political bias of the country,
yeah,
they don't want to have this data owned by American companies and stuff like that. There are different restrictions.
Yeah, I'm not sure if the question was heard by the people online. Maybe you can for next time. Okay. I think it's fine. Everybody, are there any questions here in the room? Otherwise, we'll check whether we have any questions online.
Yeah.
Mark,
hey people. Yes, we have a couple of questions actually from the social network, from the platforms that people are watching online. The first question is, what is the best challenge that your company faced with your business when you are going, let's say, outside of Spain and with the international customers? And the second question is more or less in the same way. How difficult is for a company like yours, based on Asturias, to reach this kind of international customers in this field?
Okay, I'm not sure to understand the second one, but I'm going to answer the first one, and you can repeat the other. Well, the main restrictions that we have when we go to this kind of countries of the challenges is about culture, it's about language, it's about different ways of do things. Like you mean in Angola. In Angola, people have another way of doing things. They are more quiet. They don't like much pressure, and we have to deal with this. We have to deal also with lacks in organization, lacks also in knowledge and expertise in the people that works there, and there are many things that we have to deal with, many challenges.
Okay, thank you, Abel. And yeah, the second question is, how difficult is for a company like yours that is based on Asturias? How difficult is for you to reach and to go and to get these kind of international customers?
it's about money and perseverance, I think. Basically, talking about Angola Telecom, it gets 5 years, I think. People traveling to Angola, talking with everybody, presenting proposals, etc. A lot of money spent there and a lot of work, and it's about that. It's about spend money and be constant, basically. And I think that MTC was easier, but Telecom Namibia is, I think 5 years. We have, right? It was 4 years or 5 years that we did this, the first contact with them. So it's about that. Workout.
Yeah, indeed. Congratulations, by the way, for that. Angel, there is no more questions from the platform. Thank you.
All right, thank you very much, Abel. It's great to see the efforts on the TMForum. We hope to see more of that in the future. Thank you very much.
Thank you.
So without further ado, let's move on to the next speaker, which is Jose Manuel Redondo. And for that, we are gonna move to the online setting. So let me move this away, bring this up. I think, Redondo, you can take over the screen. Yes.
Let me try.
Let me know if it
How
doesn't
about
work.
now?
Yep.
Do you see the presentation? Okay. Nice.
Put it here on the big screen for everybody, and then also put it on full screen. Let me see if that works for everybody, if you can see that. All right, whenever you are ready, it's all yours.
Okay, well, welcome on this Saturday morning here in Cloud Native Asturias, December 21. I am glad to have been invited here for the second time to talk about my stuff because we are a team, we do in our courses. And well, as I am a teacher and I don't have the professional perspective of other speakers, I have to be much more focused and much more concrete to explain what we try to do with this kind of talk, which is part of the actual course program, and what we try to transmit to the people that are learning with us to do security-related operations, although this is a hybrid between the administration and security, which are two worlds that are very tied together. But we try to establish relationship between them just because we cannot really separate them in two isolated silos and just explain they're apart from each other because it has no sense. Okay, we are in a computer science software centered degree, so we have to deal with code, we have to deal with programming, and infrastructure and security are thought also taking the perspective of code and programming. And that is the thing that I am going to try to explain here, just to show you how code and program can lead to satisfactory or successful results regarding administrations and of course attaining security for multiple products. Okay, this presentation is public in my ResearchGate page. I will send the link to Marcos and Angel later to you to access, and also the machine I'm going to present here is also public for you to download and to explore and to investigate, and why not to learn if you don't previously know something related to that, and in my GitHub repository. Okay, I like too much to make all my presentations open to the public, because I think it is some kind of way to support the community and to make the community advance in the case you don't know about this previously. Okay, so this presentation is called Infrastructure as Code Meets Compliance as Code. What's a translation, a rough translation of that is, I can show you how to develop infrastructure automatically using code, and also to put security compliance, to put a high level of hardening over each part of the infrastructure, also using code. Of course, if you use code, everything will be automated, okay? And being automated means that, as I said here, you can put it at the end of your Jenkins pipeline and embrace the full SecDevOps experience that doesn't only contain your code and your test, but also your deployment that is also expressed in code, and the securization of the deployment that will be also contained in code. Okay, we are not in the stage of developing or creating virtual machines manually. This is the past, and also in my school we don't do that, at least in my course. So we encourage people to try to create infrastructure automatically. Okay, virtual machines or container infrastructures, depending on the context, we deploy one of them or the other. Okay, and as people embrace that, we also teach our students to deploy security compliance automatically. We cannot forget that we are in an undergraduate course, so the amount of complexity or level we can give to the students is not too high, because we don't have the material time to do that, but we send the students over a very successful path that we think that will be very useful to their future or their future career, no matter which branch of computer security or computer science they choose. Okay, so the first thing we talk about is two platforms that allow us to create infrastructure as code. We deal with two. In an undergraduate course, we deal with Vagrant. Okay, Vagrant by HashiCorp, which is a way to automatically deploy virtual machines that can be multi-platform and can also be multi-hypervisor. Okay, it's just DSL language, domain-specific language, that in which you have a background file, a text file, a plain text file. I will show an example in just the next slide. And you specify in this text file the characteristics of your virtual machine. Okay, the amount of cores, the amount of RAM, and some other stuff. Once you do that, you link your background file over as something called a base box, which is something that you might create or you can download from a public repository of boxes called the background cloud. Once you do that, and you put this background file, I insist, a code file, a text file, to work with Vagrant, Vagrant will download the base box and will create a virtual machine for you. Base boxes normally are prepared to work with different hypervisors. You can find the same base box prepared for VirtualBox, for VMware, for Hyper-V, and multiple others. Of course, you have to choose carefully which base box you use, because some of them are only provided for one hypervisor and others are provided for 5 or even 7 different hypervisors. The more you have, the more flexibility you have to work with whichever hypervisor you might be provided with. Okay, in our course we work with VirtualBox, but we also support VMware and Hyper-V to be able to reach audiences with Windows machines, Linux machines, or even MacOS machines. We are MacOS friendly, and we are one of the fewest courses that can work with any kind of trouble in MacOS environments, which is something that I learned because some students told me, thank you for making your course MacOS friendly. And well, it was a side effect that we didn't plan to, but we are glad to be able to provide that. Once you deploy the virtual machine according to your specifications, you can also deploy, or you can also specify what you want to install in the virtual machine. And this is done using an abstraction called the provisioner. The provisioner is just some way in which you can express, or you can tell Vagrant what you want to deploy in the virtual machine. Okay, so you can have multiple provisioners. You can use typical platforms for an automatic deployment of configurations like Salt, Chef, Ansible, or Puppet. In the master degree, we prefer Ansible, but in the undergraduate course, we just use Bash scripts. Plain Bash scripts, which can be also a provisioner. Why? Because this way you can pick up the scripts and just deploy them over any virtual machine you have without any trouble, or without installing any third-party product. So once we have the background file and the files that automate what you want to install in the virtual machine that will be constructed by the background file, you can have everything. You have a virtual machine, and you have what you are going to install in the virtual machine. The trick is, now that we have the ability to install anything into the virtual machine, why didn't we install security? Why didn't we install hardening? And that is the second part of the presentation. Okay, so we take advantage of a system or a method to configure the virtual machine to also provide security. Okay, that's the main advantage. We can deploy a full configuration instead of providing a stored virtual machine that can take up multiple gigabytes over a couple of simple text files that you can send in a zip file as an attachment in an email. So that is very much flexible. You can provide it to anyone. Anyone can deploy your same configuration with your same installed programs in any place you like. And that is the way we develop laboratories in our course that was especially useful in pandemic remote teaching environments, in which anyone can have the same laboratory no matter the operating system or hypervisor they have. Okay, that is Vagrant. Okay, which is aimed to create some kind of environments that are tied to development or require specific characteristics of configurations. We have also, well, this is a sample background file. As you see, it's just a text file full with predefined objects and properties that are assigned values. I insist, this is public. You can explore it, and you can just learn from it if you feel like. And here, when you have provision, are multiple files we use to tell background, okay, when you create the virtual machine, please execute this to configure the virtual machine finally and create it as I like. Okay. The other option that we rather see in the master, Terraform. Terraform also is an infrastructure as code platform, but instead of using the approach of Vagrant, this is created to develop bigger infrastructures that can even take multiple cloud environments for parts of it. Okay, and there is one key difference. Apart from that, as Terraform is suited to create bigger infrastructures, it asks you if you are sure to deploy everything you specified previously to deploy it. Okay, you have a last minute opportunity to confirm the changes, because once you deploy in cloud environments, if you commit a mistake and you don't review your changes properly, you might commit a mistake, and that mistake can take a lot of money from you, because, well, you must be paying for computing hours that you are not going to use because you committed a mistake. So this tool is better suited from that. Okay, also include other infrastructure elements such as DNS and other things, but not as many as Vagrant. Okay, to work with Terraform, you need providers. A provider is like a client of Terraform. You have an Amazon cloud provider, a Google cloud provider, a Docker provider. You have to pair up Terraform with a provider to let Terraform access to the objects that work with the entity that is represented with for that provider. For example, if you want to deploy something in Amazon cloud, you need to download and install the Amazon provider to work with Terraform. Okay, so what is the difference? Well, Vagrant is oriented to the creation of development environments, okay? And it has several high-level features like shared folders, automated networks, and stuff we need for our course, but it is not directly implemented in Terraform. Terraform is designed to create infrastructures that change, okay, that evolve, and can take multiple cloud providers into the same big infrastructure, and you can work with any of them to just create your whole thing you are going to need. Okay, for a university point of view, we cannot scale too much because it takes money. So our tests in Terraform are created using the Docker provider that can be deployed locally and doesn't cost you a penny. So this is the file, a sample file we provide to install Docker locally and deploy an infrastructure of Docker containers communicated over them, just to emulate an environment of virtual machines to our students to work with. Okay, but once we have cleared out this, and I insist we favor background in our environment, now let's see what can you do inside each of the elements you can automatically deploy. This is compliance as code. As I said, there is a way to create security using a language. Okay, it is an XML language. Okay, it's a mark language. It's called it is defined, with a security content automation protocol, the SCAP. This is a protocol that have a couple of specifications, and some of them are XML-based languages called Abel and XCCDF that allow you to describe the security state of a system or of a product. Okay, are languages that allow you to specify a state, a desired state of a product or operating system, and also how to evaluate if this state is currently achieved or not, and if not, how to remediate it, how to implement that thing. Okay, so these languages allow you to define a list of elements that are called security controls. Each security controls should contain a description to tell you what it is, a procedure to evaluate if the security control is really implemented, and in case it's not, a procedure to implement it. Of course, as you see, you have everything you need to automate. Okay, you have an explanation for people who want to learn. You have an evaluation procedure to put an if. If you are not present, then remediate. That approach allows me to automate everything. Okay, and that is the thing we teach in the course, and we try to deploy to show the people how you can put security hardening in an automated way over different products. Of course, this is a protocol and defines a language. Now what we need, the files expressed in those languages that actually have the security controls defined, the procedure for evaluation, and the procedure for remediation. We need programs. We need the code to do this stuff, to do automation. Have we got to develop these files and to develop this code to do that? Of course we can, but we can also use already defined SCAP compatible files. And we are going to review 3 possible sources of already made files. The first of this is the one that comes with the package, with the most famous SCAP compatible tool, which is called OSCAP, OpenSCAP. And it is in this package, okay, available in GitHub. And you can find here a couple of predefined file, SCAP compatible files that are mostly related with operating systems. We have here an example which is related with Ubuntu 18.04, in which we can find 4 different security profiles, 6 different, security profiles of Ubuntu, from less strict to most strict. We can choose between levels depending on what we want. Okay, all are based on already defined as international standards. The first 4 are based on a French standard. The penultimate is a THIS profile, which I'm going to review, and the other is just a standard Ubuntu profile created by the own Canonical, if my memory serves well. So the second source, the US Army, the US government, they have a public repository of files that are called sticks. We have a disadvantage though. These files, the SCAP security guide packages, are free, can be downloaded, and can be applied automatically with no trouble. Okay. The problem here is that these files are better, are more complete, are more strict, but unfortunately, the automated application or this file, the official tool is only restricted to US government contractors. If you want to use this file as a baseline for your automated security the configuration of your systems, you have to develop your own automation scripts, of course, following the indications of the file that they provide to you. This file is, this kind of sources are military oriented, so they classify the vulnerabilities in 3 categories, from most serious to less serious, and also the vulnerabilities depend on the sensibility of the data that the systems manage, and also the importance or the mission criticalness of the system. So once you choose how critical is your system and how private is the data it managed, you click on some of the 9 links here, and you are provided with a listing of security controls, of stuff to do, that are classified into 3 different levels. If you access each of list, you are presented with the listing, with a title and the description, and clicking on each of it provides you with the details on how to verify it and how to solve it. This is provided into an XML document, so you can really automate it if you want, developing your own stuff or converting your own stuff, because I insist the official support from this, the automated SCAP compatible tool, is restricted to US government contractors. And this is military. If you want something oriented to civilian infrastructures, you have to rely on this, which is the one we favor in our course, the THEES benchmarks, which is like a compendium of best security practices that are developed by a consensus of 1,800 well-known companies, and are free in PDF format, and cover up to 140 different products. Okay, so you can download a PDF from your preferred product, and you have specified a list of things you have to do, full with explanations why this is necessary, an audit procedure, normally with just plain scripting, PowerShell, Bash stuff, copy, paste, and test, and remediation, that most of them are also provided using scripts. Another problem, this is, for me, is my preferred way, because I normally deal with civilian infrastructures, so this is the guideline I want to recommend. I usually like to recommend to people, and of course it's very well explained. It also serves as a very useful teaching material, but the problem is that if you want automation, you have also to pay for that. But a couple of months ago, they have provided a free tool, which is ThisCat Pro Lite, that allow you to automate the application of these controls, but only for Windows 10, Linux, and I think that a third product only, but I cannot remember which one, but only for 3 products. It's very limited, but it's automated, okay? So it's nice. If you want the full experience, the full support for all the things benchmark for all the products, you have to pay for it. So if you are a company and you want to follow this route, you have to pay this the Center of Internet Security for the full support and the full SCAP compatible tool. And the tool they provide you is have used the files in an SCAP compatible format. Okay. So if you don't have the SCAP compatible format, you have to manually implement what they say to you in this PDF, which is what I did in the final part of this presentation. Well, it is clear that nowadays we cannot put a server into the internet, an isolated server into the internet, and expect this to work or not to be attacked in a couple of minutes. So if you take things seriously, you have to deploy a tiered network infrastructure, such as this, which is an abstraction of real one that I provide to my students just to make them understand that deploying a secure infrastructure requires planning and requires careful structuration of all the machines. And as you see here, we have 4 different LANs isolated by firewalls, and a 5 LAN which is used for monitoring, validation, authentication, log, DNS, and stuff like this. Okay, so you might say, okay, this is my, imagine that I create this, something like this in my company or in my business, and I want to secure these products. Can I use these benchmarks to secure these products? Yes, because as I said, you have 140 different things. So if you explore the THIS benchmark database, you might find a THIS PDF benchmark, or the SCAP compatible if you pay for it, for operating systems, Windows, Linux of different flavors, or other OS, web servers that covers the major ones, IIS, Nginx, and Apache HTTP, virtualization and containerization infrastructure, major ones, okay? For databases, okay, MongoDB, SQL Server, Postgre, etc. Things from the control network, how to correctly configure a DNS server, how to correctly configure a Kerberos authentication server, firewall devices of different brands. As you see, we have a lot of firewall devices in the infrastructure. So if we choose some vendor that cover with the THIS benchmark, they show you how to correctly configure them. If you use servlets, you have an Apache Tomcat specific THIS benchmark. You deal with cloud infrastructure, or part of your cloud infrastructure is contained in the cloud, you have a THIS benchmark for that. For desktop software, mobile devices, Office, Apple, Google, Android, and with things that are more company-wide, like SharePoint and Exchange, for example. And even printers you have here, because printers are normally a nuisance too. So you have PDFs following the same structure, following the same approach to follow for a lot of products that usually are contained into a serious network infrastructure. And that is the reason why I recommend this to any people who want to invest in security and ask me for advice. I am no professional on this, but if someone asks me for advice, I point that into this direction, and this is the direction that I point to my students. Okay, so finally, I will show you a little sample of how this works. Okay, what I did, I basically develop or create a Ubuntu virtual machine, okay, with Vagrant. And Terraform examples on that. I'm planning to put some Terraform examples in my repo in the future, but nowadays, currently, I am very busy with things, but I am definitely going to do it. Okay, so I created a virtual machine in Ubuntu, which is just a plain installation with no extra stuff. And I use a typical program to measure security, which is called Linus. Once you install Linus, you pass Linus over your virtual machine, and Linus throws a score, a security score from 0 to 100. A plain Ubuntu installation scores 56 points, which is barely decent, or just a little bit higher from the media, for the average. Okay, so it's pretty weak. What will I do here? I will show you how to, following the SysOFI, which is the vendor of Linus advice, complemented by the THIS benchmark advice, we can greatly increase this score. And finally, I will show you that everything I am going to do here is automated using my own scripts, because I don't have money to pay THIS or other automation scores. But even if you don't have the money and you invest enough time, you can obtain very satisfactory results, because automation is still possible. Okay, so I have this base machine. Now I do the thing that is the first recommendation that most of people will give to you: update the machine. If I update the machine to the latest possible packages version, I only increase the score 5 points, 61. So an updated machine is a little bit more secure, but far from the objective. So the second logical step is, okay, put anti-malware here, put anti-rootkits, and enable the firewall. I mean, antivirus, anti-malware, firewall is like a staple. Okay, do that. Only 2 points more. So the typical base deployment, which is updates and anti-malware and firewall, only gives you 8 points over the base, 7 points, sorry, over the base. So we have a long way to go forward. How can I go forward? Following the THIS advice, following the PDF. Okay, so for example, We can install packages that prevent downloading corrupted packages from the apt repositories. We can install a log checker. We can install services that monitor the process and tell me what to do. One of the more important things, we have to install an audit service that monitors everything that is happening in my machine using the Things Benchmark auditing rules that let you collect every important event of the operating system. Even if you don't previously know how to do that, it is perfectly explained, and you can copy these rules, apply them, and collect every important security-related event into your machine. Install things like preventing people from injecting USB drives with malware, a typical tool for preventing brute force attacks, or a typical tool for preventing nmap scans or port scans of different kind. Okay, doing that, 71 points, following the Thieves benchmark advice. Can we go higher? Well, we could even start with the fourth step. This step is real security automation. Is okay, pick up the file, pick up the SCAP compatible file, and go for it. I decided to do that far at the end of the process to just make a mix between manual and automated. If I can do that, the first step, well, I could increase a couple of points, but unfortunately, I have to use the free source that is still on development. Okay, this source is free. The Thieves benchmark it includes is incomplete. It's just half of the controls, and applying this automatically over the machine I have only increases 3 points. Well, if I apply this over the base one, maybe it will increase more. But I mean, the free source is nice. It's automated, gives you more security, but it's far, far away from the paid versions. Okay, if you do the same thing with the official Thieves benchmark application, you will reach, I believe you will reach 90 points with no effort. Okay, this is what we have free right now. So I apply it, and I manage myself to put the machine in 74 points. Well, I follow the Thieves advice. I secure the SSH service, which is critical. The mailing service we have to install because some security products need it, and some more fortification according to the benchmark, and we reach 81 points, okay, which is green zone. It's secure machine. Can we go higher? Yes. Hardening the kernel. Again, reading the PDF, just reading the PDF and doing what the PDF says. Hardening the kernel and modifying the default permissions of important files managed to let me into 87 points. And most of these things are one-liners, okay? Are configuration that by default are not the most secure thing, but these guides let you put the configuration into the most secure way. I can go even higher, just reviewing the PDF files and just completing a couple of final tasks. For example, installing a password policy, disable the core dumps because we are not developing here, developing things into production machines, enable automatic updates and stuff like this, put a group password to prevent people to start into the single user mode, etc., etc. And this is the maximum that I achieve using automated scripts that I develop. 94 points, okay? Can we go higher? Yes, if I repartition the hard disk, putting some partitions into some directories into different partitions, and I manage to put my log files into a centralized log system, external log system, I might be able to reach 96, 97 points. The problem is that the effort for doing that is higher than the one that I was aiming for in this test. And well, I think and thought that the balance between effort and gain was good, leaving this in this point. Okay. This is done just following the free PDF advice. I developed my own scripts for Ubuntu 18. I put my own scripts public for anyone to review and to check, and why not to learn, to develop and configure some stuff to the best of my ability. What could happen if I want this without having to develop something? You have to pay for a commercial product. You have to pay, for example, for the ThisCat Prop tool that allows you to do the same thing that I did, but only with one click. Okay, and with a very beautiful report telling you which controls are applied, which controls are not, and if you have to manually do stuff, it also indicates you what you want to do. So, can you do it for free? Yes. Should you do it for free? Depends. I am a teacher of an undergraduate course. Shall I do it for free? Yes, because I am not a business. So it is nonsense to try to use money to make labs for practice. Of course, if I was the administrator of the networks of the university, I will seriously consider to pay for something like this to make sure that my systems have a higher baseline of security on all the times. Okay. Of course, everything can be done manually, but I insist I automated it using bash scripts that you can test in everything you want, provided it is Linux. Okay, so I put the scripts as provisioners of the background machine. So I married infrastructure as code background with compliance as code, which is not fully OpenSCAP, but we develop my scripts using a normally SCAP compatible source of security controls. What is the final conclusion? I managed to put my machine from 56 points to 94 points. And the cost of, once you do that, the cost of deploying more machines using this level of hardening is just to wait for the machine to be installed. So once you make the effort to create all of this, you can replicate your effort in any place, all automated using this kind of platforms. Okay, so as you see, we have a this benchmark for almost any part of infrastructure. So what if we decided to do the same for the rest of the elements of the infrastructure? We start to be serious about how our infrastructure can be hardened for a higher standard, and of course decrease the probability of having a serious security attack. And that is all. I don't know if you have questions about anything I said.
Yes, thank you.
So I promise I finished.
Do you hear me? Hopefully you can hear me now. Thank you very much for this very clear presentation. I do have a question myself, and then I will ask. Well, first of all, I will ask the audience whether they have any questions. Any questions here in the room? Then I'll go ahead. So I think I'd like to make a point on the distinction that you made about the educational perspective that you're bringing to the table, which is basically to set the principle of we should have some baseline for security in everything that we do in our professional life, which is pretty good from an educational perspective, as I said, and that's something that we should encourage and we should leverage in at the university. And that's so for that, I'd like to thank you for bringing that important and critical subject to life, also in early stages of their journey. Then I do have a specific question about the scripts that you have, like taking into account that you've created this yourself. It's not a let's say a product that you purchased. How secure? Because at the end of the day, the Linux and your scripts are monitoring sensitive information from whatever system, from the product that the customer has or you are building, right? So how secure are those monitoring tools in terms of dealing with sensitive data?
Well, that's a good question. First of all, apologies if the volume level was too high. I think I messed something up with my volume controls. I'm very sorry for that. Oh, that's because a question that appeared here. Well, normally you say that the first criticism I have as a teacher was that my speaking voice was too low, and it seems that I have fixed that. But well, how secure are those monitoring products? Well, in my with my point of view, every time you put a third-party product into your pipeline or into your systems, you are acquiring or assuming a risk. Okay, so how secure are these security controls, security products? I cannot really answer that because I don't really check the privacy policy of those tools. I only choose tools because are industry standards that are, oh, I have a return now, that are used in company-wide and are known, okay, are, well, has some kind of market share, several market share in companies. So the thing is, of course, once you reach that into a production stage, into a real company, you have to check the privacy policy and you have to configure each product to not to exfiltrate accidentally the data you don't want to be. Okay, for example, the log check usually is local, but if you manage to create or put into production a centralized log analyzer with a CM or a staff, you have to carefully review if this tool is not leaking data that you don't want to. So this is, for an educational perspective, this is the most suitable thing that we tried to put into production, but only into practice labs, to get the people the feeling of what you can do. Once you want to get serious into that, there are a lot of considerations, extra considerations from the business perspective that you have to consider. But this kind of business perspective is taught into the next year, the next course, into the project management course, and we don't enter into this. So the answer is, unfortunately, I cannot be precise about that because I choose the tools using another considerations.
All right, no, thank you very much. I understand that. Again, thank you very much for bringing that important subject already in early stages of the journey of the students, because that's a pretty important topic further down the line in their career. So thank you very much. I would like to ask real quick, Marcos, if there are any other questions on our chat.
Actually, there is a question for Redondo. They are mentioning, okay, today in this presentation we are talking about network design on premise. Does it make sense to try to apply this same schema, this same presentation to something like configuring VLANs on the cloud?
No, the question is right. I mean, I start to show the people the path of reaching cloud infrastructures. Of course, creating an on-premise design, it is not the best idea into several use cases scenarios. So yeah, for example, if you want to configure a VLAN into a public cloud, this has nonsense. Okay, the use case that I cover here is different, and I will try to explain why this use case is different. I always remind people that here's my presentations, that my students start with no clear idea of what is an IP, and we have to build starting from this. Okay, they cannot distinguish a valid and an invalid IP most of the cases, and a lot of students. So the path of not really knowing how addressing goes to develop a suitable on-premise infrastructure that can be later on extrapolated to a cloud infrastructure in which, okay, this box or this machine will serve as a reverse proxy, but it is in the Amazon cloud, not something that I provided. And this will be my front end, which is another Amazon instance, and which will be my back end, which is another Amazon instance. I mean, we want to create into people the mental map that you just not throw a server and put the server to go into it, but you have to think into a layered an isolated network environment, and which can have VLANs. We use this on-premise stuff to explain VLANs because people doesn't know what is a VLAN. And now you can put out these concepts you learned into a real production system into the into real environments, of course, in the cloud. One of the things that surprised me the most is that most of the speakers in these events have the business perspective, which is better than mine. I am a teacher, so even if I have some knowledge about the business perspective, I have to think what can be most useful to my students to have a baseline that make the jump to the business stuff easier. So yes, you are right, but my use case is different because I deal with a different kind of professionals. I deal with proto professionals. So I'm sorry if it is not what you expected.
I think it's pretty good. I think I already said it. I'll reemphasize that it's a pretty important effort, like bringing that subject early on in their career. So thank you very much for that. Are there any other questions, Marcos, from your end?
No, at this point, all good. Again, thank you very much, Redondo, for this amazing talk as usual. Thank you.
Oh, thank you for that. I will send you the link in case anyone is curious. Okay.
Cool. Thank you.
So,
come back to you, Angel.
All right, we have now a break, so we'll take a few minutes to. We are running a little bit behind schedule, so we'll just switch laptops because Andres is going to give us a nice demo in a minute, and once we are done, we will be back on stage. Thank you very much.
All right, here we go again. Thank you everybody for stay tuned. I really want to thank both the speakers that we have so far, Abel Ruiz and Jose Redondo. It's a pleasure to have this talk with you guys. Abel, just amazing talk about the life cycle and all the things that they are doing in the company within Aviles here in Asturias, and also Redondo, well known in the community. All the learnings that he has from the university, apply it to actually, I would say many things can be applied on the daily basis of a company, even though some use cases are very, very focused on the learning path of the people on the university, right? So, okay, the break is done. We are ready to continue. We have, of course, two amazing speakers coming along as well. First, we will start with Andres Torres, that I will make it available very, very soon. And also after that, we will have Ravi directly from Atlanta. So I think it's enough talking to me. Andres, hope you are ready. So the stage is all yours.
Hello.
Yep. Can you hear me?
There, no? Okay.
You have a bit of echo over there.
Yeah, we have a little bit of echo because we have the audio outside of my laptop. Let's give it 2 minutes. We're gonna work on it.
Sure. Thank you. In the meantime, yeah. Again, this is actually, I was mentioning at the beginning that this is the kind of the anniversary, the birthday of Cloud Native Asturias. We started with the idea on September 2020, but the very first event was actually in 2020, in December 2022. And actually, we started like very, very, very hard. We did like one event per month. And yeah, of course, it's with all the COVID and all the stuff.
Marcos, perdona, ¿ahora va un poco mejor?
You have a bit of echo still?
Sí, bueno, yo ahora tengo algo de eco, pero menos.
Okay,
No sé vosotros cómo lo oís.
Maybe we're gonna start. I think that's okay, Andres. Go for it.
I cannot hear you completely, but I can go on if you guys hear me without echo.
Let's go for it.
Yeah, okay. I'm gonna move on with the presentation. Then for questions, etc., we will figure it out how we do it later on. So my talk is about cloud native development. So some of the tools that we learned in my journey to the cloud. So in my previous talk, when I was here, I think at the beginning of the year, in March, around that, we had a conversation about the journey of my company from on-premises deployments from different customers to the cloud world where we are now and moving to a SaaS model. We went through a lot of steps, we went through a lot of mistakes, and we learned a lot about how to develop in Kubernetes environments from our local setups. And I'm going to present you some of the tools we use. There are more, but well, the ones that for us were working or are working the better. And then we're going to demo some of these tools so you can see how they work with a remote cluster. So this is the presentation. We're going to go through the usual ways of development that we used to have until now. I'm not sharing the screen. I think I'm sharing for the online, but not here. You are sharing your browser. But do you see the presentation online, but here for this TV? I need to mirror. You carry on because we are not seeing here, but I will in a moment. I think it's doing the mirror now. No.
No, don't worry. I think it's just I need to set it up here.
Okay. I'm going to read the agenda. So it's going to be about traditional development, how we introduce the container in the traditional development, and then the CI-driven development. And then the pros and cons of all of those, and then also the solutions available, some of them. We're going to go through them and going to demo some of them. For me, well, I'm Andrés Torres, and as software engineer from Spain. At that time, when I prepared this presentation, I was living in London, but not anymore. I'm back to Asturias. I'm back to Abel, where I'm originally from, and I'm working for a Dutch company for the last 6 years. It's a fintech company. It's called Backbase, and I'm there working as a director of backend. I used to work there in Amsterdam, then in London, and now back to the starting point, working from Abel, from home. Most of the days in pajamas, like most of you, using a lot of calls, etc. But well, that's the day-to-day. If you want to find me, well, we can have details later. But well, my Twitter is there, my LinkedIn, and my website is atorres.es. And then we're gonna go now for the explanations. What do you want as a developer when you are working building solutions for your company or for your customers? So as a developer, what you want is to set up your laptop, your development environment as quickly as possible, and something that you can also reproduce. If you switch laptops, if you have new joiners in your team, new joiners in your company, you want for them to install the whole thing as fast as they can, and also everybody using the same thing. Because, well, you want to be reproducible, you want everybody to work in the same way. You want to have, if possible, a production-like replica of your application because, well, you're not building in your machine. You're not going to share your machine to the rest of the world. You want something that is closer to what the customers or the users of your application are going to be using, as close as possible. And you want a fast inner loop in the development workflow. The inner loop is everything that you do from code, build, deploy. So every time you build something, you code something, you want to deploy it somewhere and see how it works. That's the inner loop. The current status for this is, well, if you're still working in a non-cloud setup, you probably have something similar to this, a traditional local development. So you are coding something, you build it, you test it in your machine, and you keep going. That's the classic works in my machine. So you have it working. It used to, when I started coding a long time ago, it was like that. So I was deploying in my local machine. My local machines, I have a Tomcat or a Yeti or a similar thing. I was deploying my WAR. Because I've been doing Java, but if you're doing JavaScript, etc., the same with a node server, and you've been coding, seeing the changes, seeing how it goes, and then at some point you ship that deliverable somewhere and they deploy it for you. That was the traditional way. Shipping that deliverable, that WAR, that jar, or whatever, it was not an easy task and normally was separated from the development workflow. So you finish your development and then you give it to somebody, our operations friends, our system engineers, and they deploy it for you. Sometimes it's not working. They need to come back to you. Hey, what do you do here? No, you need this configuration file. And you used to have this clash between them. The developers thinking that the ops people don't know how to deploy their software, and the ops people thinking these guys don't know how to code. So that was when the whole DevOps culture appeared, the way of working all together instead of throwing things through the wall once to the other. You work in the same room, you deploy all together, everybody knows about. This is the fastest one. You're working in your machine, you are seeing the code changes, and you deploy them also in your local. That's the fastest one. As a developer, is the fastest one to see the changes that you're doing and getting feedback about what you're building. But for the organizational level, etc., is complicated because works in my machine is the typical excuse, but then in production is not working. There is a misalignment between things you need, etc. Especially in the world we live today with the infrastructures that we saw in the previous presentations with all the security levels, gateways, reverse proxies, Istios, meshes, a lot of the stuff you cannot replicate in your local machines anymore. So you need something more reliable. So when the containers appear some years ago, that was easy to replicate, to make the replica of what was the production environment, or at least the same machine, to be using the same machine. So you have a container with your Tomcat inside, and you deploy the same way across everybody in the team. And also with Docker Compose, Minikube, Docker Desktop, it's allowing you to run some of these if you are in a microservices setup or working with multiple services. It's easier to deploy multiple of these. You can have your database running local as a Docker. You can have your MQ, a Kafka, for example, an ActiveMQ, a Rabbit. You can have 2, 3, 4 services, whatever your application is using. Of course, if this goes to really huge numbers, for example, my company will have more than 60 microservices these days. So that's not replicable anymore in local. You need, even with these machines as we have here, 32 gigabytes of RAM, etc., you run out of power in your machine. So it's slower for the developers. It was more replicable and easier to deploy. If you give a container that is working in your local machine to your system engineer friend, they're going to deploy it probably the same way in production. So it's easier for them to do the changes. They don't need to deal with issues, even though there are also configuration details that can change between environments, of course. But for the developer, it started to be a pain in the ass because you need to introduce this build Docker in your inner loop. And it's not an easy process. I mean, it's not the end of the world, but imagine that compiling normally takes, I don't know, depending what language you use, but 10 seconds, 20 seconds. Building a container and doing the whole thing is bigger. It can be around minutes. So I will get a coffee in my continuous building. It started to be something that we used to say in the company. Everything is building, I'm going for a coffee break or a smoke. And then you have now for example, my company is now, together with some of the solutions that we are seeing, the CI-driven development. So you cannot use your local machine for all this because, as we mentioned, we have 60 microservices. You also have different layers that are there, different databases that we support. We support Oracle, MySQL, SQL Server. You cannot have replicas of all that. So what you are doing is you are coding, you are building, you are committing, and then in our case, we are using a tool called Jenkins, but can be GitLab or any other approaches like that. You have a CI process that is getting your code, building a container or building whatever deliverable you have, a water or a jar, and deploying it in a staging environment, which is a little bit of a replica of what is production with everything you need there. The databases, the enqueue providers, proxies, service meshes, if it's a Kubernetes cluster, whatever you need. The problem with all that is the waiting time. So as fast as it can be, we can, in our company, sometimes we create an environment from the scratch, creating the whole cluster, etc., plus deploying the applications 5-10 minutes, depending of the day, because also when everybody is releasing at the same time, at the end of the month, when we're going to do release time, Jenkins is suffering. So we need to increase the machine power, we need to duplicate, sometimes the threads die, so we have plenty of problems, and sometimes the builds take more than 20 minutes, for example. And that's, as a developer, waiting to fix a problem, especially if you're in panic mode because it's a bug in production, etc., that's not a good cycle. Testing everything in local is also not doable anymore, because if not, what you are doing is mocking the rest of the ecosystem, and that's fine in some basic scenarios, but the reality is that mocking everything gives you mock confidence, per se. You are not super confident that what you are going to put in production is really going to work. So those are the three, more or less, that at least in my company we've been through, and I know for other colleagues and other companies that they are more or less in the same three. And to summarize the behaviors of these three, you can see with happy or not that happy phases. The traditional local development, from the point of view of being production-like, it is not. Your laptop is not production, especially in the world we live today with microservices, etc. It's not really replicable. So between laptops, etc., everybody installs different tools. Everybody has different machines, etc. Windows, Mac, Unix, etc. But it's the fastest one in the inner loop. In the build, compile, and see my changes is the fastest one because you are doing everything in your laptop. The container-driven development helps in the production-like because the containers can be reused and is normally the similar approach to build them. The replicability the same, but as a developer, you need to wait a lot of time for these builds to happen. For the CI-driven development, you are deploying in a production-like environment, so is the best option. You replicate by doing the same builds every time, but it's the slowest one as a developer. And we're going to see now, comparing how slow and what's the difference between the traditional and the CI-driven one in numbers. None of them are ideal. Some companies are in one or the other, but none of them are ideal. But there are tools to mitigate some of these problems. From the developer experience, comparing the traditional with the container CI approach, if you introduce, well, we make some assumptions here that maybe are not true in every level, but assuming that from a classical 8 hours day working, you are coding, you wish for 6 hours between meetings and a lot of stuff. That's not the reality, but let's put 6 hours that you are effectively working. Remove these other 2 for any other extras. If you do an iterative loop of 5 minutes, you put here 3 coding, 1 building, compiling, and testing. That's about 70 iterations during the day that you're building and seeing if you are building new features, if they work, and you're seeing new functionality, testing that everything works, etc. The developer tax that we call here is the commit time. So between you commit to save which is saving your advance. If you move that to the containerized wall, and we introduce a non-crazy 4 minutes for building a Docker images and deploy it, etc., you are reducing these 70 iterations that you do per day of building new features to 40. So that's a 40% decrease in the developer productivity, for saying. Taking these numbers, but if you reduce the numbers in general, at the end the percentage is similar, that you are introducing a lot of noise in the cycle of I want to build things and see how they solve problems. I don't want to deal with infrastructure or waiting for environments to be created. So it is quite expensive if you look in a company for, I don't know, in my company we are now 1,500 people. Developers, I think it's around, in my department, which is R&D, when we are building the products, around 600, 500, 600. So if you put all those numbers together, you can see how many hours we are waiting every time if we need to wait for environments to be created, etc. So we went through multiple testing solutions, etc. At the beginning, we were using, like I was mentioning in the previous talk, background to recreate the same environments across and do the deployments in the same way. But the more we got into the distributed world, the more we got into the microservices world, background was not enough, and it was consuming a lot of resources. Because at the end, background is like a mini laptop in your, well, a mini computer in your computer. It's getting all the resources at the moment you start the machine. So if you give 12 gigabytes of RAM, it's going to get them, even if it's not using them. Docker is using only what it needs. So Docker was a better approach. We moved to Docker Compose, but then that was when we had 3, 4 services, 6 services, 10 services. Now we have 60. It's not doable anymore. So we explore other solutions. We're going to cover 3 today, and I'm going to try to demo the 3 of them. So if it's difficult to do one demo and do it properly, it might in 3 in a row, but well, I will make my best. Scaffold is a tool from Google to actually, what the Scaffold is basically doing is moving the CI pipeline to your local machine and automating the whole thing. We're going to see it now, how you're going to do all the stages that you will do in a CI setup, building, preparing the container, deploying to Kubernetes, etc., but from your local machine and automate it. So it's not really making the things faster because the builds still need to happen, but at least from the developer point of view, you only focus on the coding and everything happens behind the scenes. We're going to see how that happens behind the scenes. The tool normally works, Google also has another tool called Jeep to build Docker images, so normally the people use both all together to build the Docker images and then Scaffold to do the rest of the piece. Another tool, which is not an alternative so some of these tools can be used together. Like Scaffold and telepresence are normally used together. Telepresence is a way to debug your service in a cluster, because it's allowing you to have everything, your 60, 100 microservices in the cluster. You are building one in your machine, and then what telepresence is doing is basically proxying the traffic to your local machine. So if I start my service in my local and the other 60 are running in the cluster, but they need to call my service, there is a command called intercept that is basically going to send the traffic to my laptop so I can do code changes in my laptop and see them reflected in the whole cluster. So it's useful to debug, it's useful to do mini demos sometimes with small changes, etc. So we used to use it together with Scaffold, because Scaffold helps you to automate the whole deployment and telepresence to do the debugging part. And then a tool from a Spanish company called Octeto, which I will call it, the guys from Octeto, maybe they have a different definition, but for me it's like a Scaffold plus telepresence on steroids. So you're going to see how it works, but it's giving you the both things, like automating the whole deployment, etc., and then also allows you to debug from your local. And I think the main difference, or what they normally remark in their presentations and in their website, is moving the building part from your laptop to the cloud. So it's doing the same thing as a Scaffold, but instead of building in your laptop, in your local machine, it's building in a container in the cluster. So you can have a laptop without Docker, without Kubernetes and everything, and you just put your building part into the cluster, and it's using all the power from the cluster, etc., etc. So it's not using your laptop for that. So that's another extra. They also have a product called Octeto Cloud. When they give you the clusters themselves, they manage everything for you. But you can also, if you get the business version of it, you can also install it on your own clusters if you want. They did a presentation for my company, Pablo de Guzman. They are really open, so if you contact them and you want demos for your company, also they will be glad. There are other tools there. I mentioned just another 3 that I know for presentations or conferences. Garden, Tilt, and Bridge is all in the same area. Like, I want to work in a cluster with tens of services, even sometimes hundreds of services. I cannot reproduce that in my local. How do I work with that in an efficient way? So all the tools are around the same, but well, we are not going to cover those today. For an explanation of a scaffold, at the end, what you need to do to install a scaffold is installing a CLI, a command line tool. And at the end, in the diagram, you see that it's basically connecting a lot of different processes inside of a pipeline. So it's not one single pipeline that you always need to follow. You can plug and play with them. For example, the building artifacts, it works with Git, which is, again, the other tool from Google, but it's also working with a plain Docker file if you have it, or it's also using Bazel, or maybe they're going to introduce more in the future. To do the Git commits, you can also define how you want to do it. It's based on the Git, in the tagging of the image, it's based on the Git ID or a hash, a number, or the date and time. And then how you want to deploy is also something that you can decide. You want to deploy with plain kubectl, you want to use Helm charts, you want to use customize. So again, it's a CI for your local, and also you can plug and play which ones you want to, and you can have profiles even. So for my local, I want to build with Docker files, and I want to tag it with the hash, and I want to deploy using kubectl, but you can have a profile for Google Cloud when you're building with Git, when you're deploying with the Git commit ID, and you are using Helm, for example. So you can have several flavors of it. It's really easy to configure. But again, for the comparison we were doing at the beginning, is doing the same things you were doing manually. So I'm coding, I'm going to build my Docker image, I'm going to push my Docker image, I'm going to deploy in Kubernetes, etc. But it's all automated, working for you behind the scenes. So the time is reduced at the level that it's automating your manual commands, but the builds and everything needs to happen anyhow. And if a build is taking 5 minutes when you do it, when a scaffold do it, it's going to take 5 minutes. So it's not saving you time for that, it's automating the whole process for you. Again, it's open source from Google, etc. Let's do a mini demo of this. You have examples in their GitHub account. So here they have a whole examples section when you have for all kind of languages. I don't know if this is too small. With using build packs, using Docker files, using Helm, using kubectl, using Git, as we mentioned, etc. So we're going to do a mini demo using build packs, for example, for Java. So instead of having a Docker file, what the build packs are doing are you're pushing your jar or your war. The build packs are packaging everything into the Docker images for you. So I'm going to clear here a little bit. You see that there is a scaffold file. This is super small because it's doing only, the rest is all using defaults. But well, you are defining that you're using build packs. What build packs are you using from Google? And then, well, the Google runtime that you're using, etc., etc. You can have more things here. As you mentioned, you can have profiles for local, for Google Cloud, etc. And then the file can grow quite a bit. And it's based on all the pipeline stages that you have here. So you can have a section for init, for building, for tagging, testing, deploy, file sync, because at the end it's going to be reading your local to deploy, how you tail the logs, port forwarding, how you do the cleanup, etc. So all that can be defined in this kind of file, the scaffold YAML file. But if you want to work with it, the only thing you need to do is scaffold dep. And it's basically going to get whatever you have there. In this case, it's a Maven project for Java. So it's going to build it, the Maven and Java part. Then it's going to create that Docker image out of it. is going to push the Docker image to the cluster that is connected from my laptop. I'm deploying in an IBM Cloud demo one. And then it's going to be available for us. So if I go to see what's in the cluster, there is this web pod. So this is the one that we just deployed. We see that is, let me see what service it is. It's exposed in this. So if we go here now, this is what we have there. So it's a normal Hello World application. I can show it a little bit, but no, this is the Go one. This. So it's showing here Hello World, nothing fancy. What is cool from this is, okay, now I'm going to make a change. We're going to change Hello Cloud Native Asturias. The moment you save, Scaffold, what it's doing is it's actually reading from your file system. So every time it's detecting any changes in your code, it's going to do the same process all over again. So it's going to build the jar, it's going to create the Docker image, it's going to push it to the Docker container registry, it's going to get the Kubernetes or the Helm, whatever you have defined, and it's going to deploy it for you behind the scenes. So now we're going to see what it's doing here, but you could be coding there. And this is going to happen when you finish, when you save the file. The process is going to go faster depending on the changes you do. So now I only change a piece of a class. If I change the libraries, for example, in the Maven, if I update the version of Maven Spring Boot, it's going to take longer because it's going to download half of the internet like all the Maven projects do. But for now, it was faster because it's changing the latest layer of my Docker image. It's deployed now. And if I go to the same instance, I see that the change is there. So I'm doing changes in my laptop, and after seconds, depending on your build and minutes, you're going to see them deploy it automatically there. But you as a developer did nothing. You only changed your Java class, and everything happened behind the scenes, and you have a change available. So that's the benefit from Scaffold. It's removing the whole plumbing that a developer needs to do these days to put things in a cluster in Kubernetes, etc. And it's doing that for you behind the scenes with any changes that you do. But at the level of speed, it's still doing the same steps. So if I'm a developer, yes, I need to go make the Maven build, and make the Docker build, push, etc. Those things are automated for you, but the things need to happen. That's the point. So this is Scaffold. We use it. We have developers using it in the day-to-day because, well, depending how you are coding, what you're doing, especially in the front end, can also have a fast loop. But you still need to have this process of building, and sometimes it's slow because, well, the builds are slow anyhow. You are not speeding anything there. So another tool that we mentioned that you can use together with a Scaffold when you have a different scenario is telepresence. So when I did this presentation in my company some time ago, it was the version 1 of telepresence. If you go to their website, they still show telepresence 1s there. And they mentioned that they did a migration. They changed the whole thing. So the idea is the same, but the architecture and everything behind is totally different. Telepresence 1, the legacy version, it was basically swapping. Actually, the command was telepresence swap. So it was basically you run your Docker container in local, you have your containers out there, and it was swapping the one in the cluster for yours. So the cluster is thinking that this is the one they need to use, etc. So the problem with that one, it was not that stable. If you have disconnected with the cluster or whatever, then the cluster is destroyed. It's unstable and it's not working anymore. And you still need to have this build process every time in your local from the Docker. So it's also not super fast. They changed the whole thing and they adopted an approach using a sidecar proxy. So similar to what you do with service messages that are injected in your pod, the same you're going to have. You see a little bit here in the traffic, in the graphic they have. You're going to have your pods running in your cluster. You're going to have your local running. And then you're going to have a command called intercept that is basically that proxy is going to send the traffic instead of to the normal pod to your local machine. So it's faster because if you have these automatic builds in your local, etc., any changes are directly reflected in the cluster, etc. You don't need to build the Docker. and you are not modifying the cluster per se. So the cluster is there, all the pods are there, you are not substituting pods, everything is there, but the proxy is just sending the traffic one way or the other. When you disconnect, the traffic agent keeps going the traffic in the normal way, and everything works the same. So you are not making the cluster unstable, etc. So it's a better approach than the telepresence one. We are using it now recently. We did presentations around the company. We have developers using it. Our company is using a mesh, a service mesh. It's using Istio, which is another proxy in the same pod. So we thought that will be some collisions, etc., but it's working properly. I think they have issues with other meshes like Linker. I saw in the GitHub issues they have something there, but well, I think they just need to work the problems. But well, it's a useful tool for an example like we're going to see now. We have several microservices. You want to troubleshoot something, or you want to do a small change of POC. It's a nice tool to do so. The tool is coming from a company called Ambassador. If you use Ambassador clusters, they have some extras that you can use, like the personal intercept, because well, we're going to see now that, well, we're going to demo now telepresence, but if you go to their website, they have a nice explanation of the types of intercepts they do. So we're going to now try the global intercept. So I'm going to intercept to my laptop, but it's the whole cluster. So if you guys will call the same IP address, etc., that I'm going to be calling, all your traffic is also going to go through my laptop. If you are several developers working together, that can be a little bit of a pain. So they have the concept of personal intercept. So I can be the only one doing test and intercepting the lab. So at the end, what you're sending is a cookie that is going to be passed. So if it's not that cookie, then the traffic is going to go in the normal flow. So I'm the only one intercepting that. When I do the first call to trigger the whole flow, I can do that. But that's only working. We're not going to demo this one. It's only working if you use Ambassador. If you use a normal cluster, you're going to need to go for the global intercept. So we're going to do that. In this cluster, I have 2 microservices already running, 2 Java microservices. One is calling the other, and another microservice is calling an endpoint in the internet. Let me see if I have it open. No. This one. There's one service that is going to receive the call. That service is calling. Well, we can do the hello. We are in this service. This service is calling another microservice. And this another microservice is calling an API that is returning Chuck Norris quotes from the internet. For whatever reason, if we want now, if the audience for our demo is not Chuck Norris friendly, but they love cats, we can do a change in this service in our local machine to point to a website that is returning something about cats, and it's not going to affect the cluster. When I disconnect, the whole system is going to keep working the same, but all the traffic is going to go through my laptop now. So if we go to the telepresence one, again, it's a CLI that you need to install, and then there is a daemon that is running in your local. It's going to be now started the moment I do this. So it's going to check the services that you have deployed in your service. As you can see, I have these 2, another in Java, and those 2 are here. It's ready to intercept, but it's not intercepting anything yet. What I need to do is telepresence intercept. What I want to do is, when I'm doing this command, is telepresent intercept, please, another telepresence service that is going to be running in my local machine in the port 8090. And then I pass an environment file, because when you do this, it's generating this file with some environment variables that telepresence need to work. I can show it to you now, but it contains the ports and the host, etc. So I'm doing that. Everything is working. So now, if I run this service locally, and I'm going to do it now here. So if I run this in my local machine, and I put it in debug mode, for example, I can put a breakpoint and the traffic is going to go from the internet to my laptop and I can debug it directly from here, which is quite cool and quite useful in some situations. So this thing is now running in my local in the port 8090, as we mentioned. If I now do the same call that I was doing before, my ID appears here, and now I'm debugging. It's a call from the cluster that is redirected to my laptop, so I can do changes live, I can test things, etc., etc. So for now, we're gonna do nothing, but let's do a change. So instead of Chuck Norris quotes, let's do some cuts facts, and let's restart. If you have something that is all the time restarting, like for example, this is a Spring. If you have a Spring Boot dev tools, and you don't need to do the restart that I did, it's going to be auto-deployed by Spring, and you will see the changes. And if you're using Node or any of these tools, it's the same thing. It's going to be more than clicking it. But well, it's deployed again. And now if we do the call here, again, it's going through the change we did. And now instead of whatever we are doing before, calling one service, now we are calling the other, because imagine that instead of calling the dummy services to return quotes, you are calling production environment, dev environment. So you can do that change live to see where the data is coming from, stuff like that. Or debugging directly, like just plain debugging is already super useful. We use telepresence a lot in the company for that, for debugging in the cluster to see what's going on in the middle of, here we are talking about a flow of 2 calls. This service called this service and another service. In my company, we have sometimes flows of 6, 7 microservices involved. So you don't know sometimes what is happening and where it's happening. We have tools for tracing and observability, but sometimes you need a good old debug to go through the problems. So that's telepresence. And then the final one I wanted to share is Octeto. And again, for me, and I don't know if Pablo and the guys from Octeto agree on the definition, for me, it's a mix of these two that we saw, plus some extras that they have. So if you go through the presentations that they have in the website and in other conferences, they talk a lot about the inner loop, how to improve the inner loop, etc., etc. So they also have an explanation in their website about how it's different from tools like Scaffold that we just saw or others. And I said, well, Scaffold is what we mentioned. It's automating the whole workflow, but it still need to happen, and it needs to happen in your laptop. And it can be as slow as your laptop it is. What these guys are doing, and the click that they did, is moving the whole thing to the cloud. So you're not using your laptop to build, you're using a container in the cluster directly. So you're building there, you're using the resources from the cluster, etc., etc. So that's a really interesting approach. So you're moving the whole development to Kubernetes. So no commit, build, and push or deploy required in your machine. It's all happening there. So we're going to see an example. It's also coming from the examples they have. Well, this is what you see if you're using Octeto Cloud. So well, this is the Octeto website. You can try it for free. They give you a cluster with limited resources. I think it's 4 gigabytes, etc. But well, you see that I already registered and I have this demo for a while. They also have the business solution, which is you deploy Octeto in your own cluster. So you don't need to use Octeto Cloud, but well, they are offering an extra solution there. I have my namespaces. I have previews that we can talk later on. That is also really useful. But let's demo something easy just to see the power of Octeto. So let's deploy something in this namespace that I have. They have all these. They included more things since the last time I was testing. At the beginning, was only supporting GitHub, but now you can deploy for any other GitLab, Bitbucket, etc. And you can also go to a catalog of Helm charts and click and choose whatever you want to deploy: a database, Drupal, Prometheus, etc. Let's try with the demo they already have. So they have a movies sample app that you can deploy. So we're just gonna put the URL of the GitHub repo and deploy. So if you go to that repo, if you go to this, you see that they have this file. So similar to the Scaffold YAML that we saw, which is a file with configuring the steps, you have another one with Octeto, which is actually telling you, hey, you need to deploy these applications with this commit in particular, call it like this. you have a YAML in every application. So we are deploying an API, we are deploying a front-end app in React, and we are deploying a database. In this case, I think it's Mongo. Yeah, Mongo. So the three apps are deployed following the approach they have for the Octeto Cloud. But the interesting part from the development point of view, so Octeto Cloud had many good things. That's why I said that if you are interested, also check it. But from the developer point of view, the interesting part is how you can start working in the middle of the cluster with your local code. So let's go to, this is the repo. I have it clone it, and then if you go here, you see that they have the API application, the front-end application, the Teto pipeline, and they use a Helm chart to deploy. So if we go to the API part, for example, well, let's check that also when you deploy things here, they also give you addresses directly that you can click and do a preview, which is also really useful. So if we go to the front end, they have these endpoints already exposed for you, and then you can see the app up and running in the internet. They have the concept of namespaces, so you can have these URLs private, so only the people in the namespace can see the content of this. They have previews that they can generate these URLs from a pull request in your repo. So in doing a pull request with changes, they're going to have a preview with my changes deployed, so you can see what is included in my pull request. Well, imagine a scenario where we need to troubleshoot this application. We see that movies and continue watching are kind of the same list. So somebody made a mistake here because we are seeing the same things twice. So let's go to the code and see where the problem can be. So if we go to server.js, we have a call to movies that is getting the data from movies. We have a call to watching that is getting the data from movies also. So there is an issue in here. We need to fix this. What's the process as a developer using Octeto? So you go to the API, what is, well, the service that is with the problem, and then you do Octeto app. Or maybe I need to do Octeto login first. Yeah. So what I started to do now is creating a container, put that in the cluster. So whatever I'm doing now in this terminal is not happening in my laptop. It's happening in the cloud, in the container that they just created in the middle of the cluster. So if you're already deploying in the cluster, so you're already coding in the cluster, the deployments go super fast because you are in the cluster already. So that's a benefit, of course. And you need to disconnect the whole, I need to build, push the Docker image. No, you just need to do the same thing you will do in your local. So starting your application in local, starting your application in the cluster has the same effect because you are in the cluster. So, well, everything is up and running. I have it here. If you go now to the app online, it's going to fail because the API service is not up and running yet because I just started the container. The container is waiting for me to do something. So now it's doing nothing, so I don't have an API with movies or with nothing. You can see it here that is in development. I don't know if you can see it properly, but it's now marking this as in development. You can disconnect and we will back to normal, or you can work like we're going to do now. So at the end, this is a Node application. So if I go to the Node application and we fix the problem that we mentioned, that this should be calling watching, we save this, and now we run it. With up. If I do the yarn start, now my application is running in the middle of the cluster, as we mentioned. So until now, it was failing to do the call, but now that my application is there, it's gonna return because I'll have it here now. Yeah. So I'm running it like I will run it locally in my laptop, but it's in the middle of the cluster. So it's already responding and with the fix that we just did. So the continue watching list, you see that is different from the movies list. So this is quite a massive change in the developer lifecycle because you are not dealing with, so it's what we mentioned, Scaffold is automating the whole thing, but it's not, at the end, you're still doing it. This one is doing it directly in the cluster. So you don't need to deal with, I don't even care as a developer how to build a Docker image or whatever. I'm just working like the same thing I will do in my local if I wanted to show you my app, but I'm in the middle of a cluster. So you can actually check the cluster, you or anybody working in my same team. So this is Octeto. They have more things, of course, that because Octeto is one option, and then you have the Octeto Cloud. The whole thing we mentioned about the previews, the namespaces, what you can do to deploy, that you can have a catalog from the internet, but you can have your own private repos. So in your company, if you have a list of charts with your services, you can click and choose from here. Your personal GitHub, like I have, so I can also deploy from here directly every time I want. So it's a really cool tool, and it's like the next level of what we consider the life cycle of deploying in clusters in the cloud. And that's it. I don't have much to present. All the demos went okay. That's the first. And thank you for attending. And if there are any questions, happy to answer.
Thank you very much, Andres. I guess for the questions, so that we can also listen to the other guys who will use laptops. Just real quick, let me switch hop on and off, and then start. Let's see, from here, we'll also use.
Andres, Angel, we cannot hear you now. I don't know if you have any issue over that. Let's see if they are able to fix it. But yeah, amazing talk from Andres as usual. Let's wait a little bit. We cannot hear you, Andres. We cannot hear Angel either. However, I'm checking if there is any question in the internet. I have a couple at least, but let's wait until you have the mic up and running. Now we can hear you, Angel.
And let me put here the presentation again. That will be the next one, but just to have something on the screen. A little bit of admin work here for me to do, as usual, but we are back again. So thank you very much. Thank you very much, Andres. I have a few questions, but let's first of all, let's see if Marcos has have any questions from the audience. So
yeah, one of the questions that we're discussing.
One more thing, if you pass me the speaker, just one thing, Marcos, just so that we can hear you. Could you try now to say something?
Can you hear me now? Can you hear me?
Nope.
Okay.
Still not there yet. Just one second. Okay, here we are.
In the meantime, people that is...
Say something now?
Can you hear me now? No? Okay, can you hear me?
Yeah. Yeah,
perfect.
That's fine.
Now, I was mentioning, Angel, that we were discussing on Twitter. One of the questions that people had for Andres is, okay, you introduce Scaffold, telepresence, and Octeto. If you would have to choose, which one would you choose?
So if I needed to choose, and in my company I have some decision power making, and so we went for a Scaffold and telepresence, but we were in conversations with the team from Octeto. They came to do a presentation for us and for everybody, and we are in conversations with them. So probably if it was my money to decide, I will go for Octeto straight away. Even though the other tools can also, I mean, they are not like one or the other. You can also use telepresence for a punctual thing. Scaffold can also automate, but well, if you have Octeto, it comes with everything included, so it's a one for all. The other ones you can use independently and are free, which is also, of course, something to take into consideration. But Octeto also give you the cloud setup. They can deploy it in your own clusters. They have the protection per namespace using Google authentication. So they have a lot of extras that if you go for there, probably the other ones don't have, or you will need to build yourself. And sometimes it's always this thing, like, where do you want to put the money? Into building solutions that are out there or paying for the solution, right? And also it's a Spanish company, so it's also a good thing. Yeah.
Cool.
So if that's what, for me, go for Octeto, yeah.
Cool. Thank you, Andres. Angel, no, from this side, I think we are good to go, taking into account that we are running a bit late.
Okay, so let's go back to the next speaker. I think we have Ravi already with us. Without further ado, I'll give you the stage.
Hey. Can everybody hear me? It looked like I just
Ravi.
Okay, perfect. Yeah, I'm in the right spot. So
you are indeed.
Yeah, cool. I really appreciate you having me today. I really like Andre's presentation. Anytime you could use the Chuck Norris API, it's a great presentation in my book. So let me go ahead and get started here. It's because I went after him. I learned the trick here. So can everybody see my presentation?
Yes, indeed.
Okay, perfect. Well, I'm Robbie Lockman, and again, thank you so much for having me at the conference today. So my talk is about, well, you've heard of infrastructure as code, aka IAC. What about the application? So I'm going to be introducing a concept called application as code, or AAC, and kind of walking you through a little bit of a journey, how we came up with AAC, and just talking about some complexities in software development. So a little bit about myself. I'm Robbie Lockman. I'm the field CTO here at a firm called Shippa. We're the provider backing the open source project called Catch. And a couple things, never got something right the first time. The older I've gotten, if I get something right the first time, I know I didn't do it correctly. And trial and error makes software, right? So iteration is super key when you're developing something. And so a couple firms I used to work for before Shippa, I was a chief architect at Harness. I spent time at Mesosphere, Red Hat, and IBM, so it's kind of the trio of distributed systems firms. So I built a lot of distributed systems for the public and private sector here in the United States. So what are we going to be talking about today? So kind of three topics. At the surface, it can seem easy, but there's a lot of nuances between them. So the first one is, well, rising developer complexity. There's lots of ways to do stuff and lots of ways to deliver things. Why do we have to be putting through all this complexity? And really talking about this concept and this up and coming discipline called DX, or developer experience. So it's a lot like user experience. So you're as a consumer, or your experience with consumer products, but the end user is a developer. So there's kind of two parts. If you're a platform engineer or a developer, they might mean a little bit something different. And then a journey to application as code. So some of these same abstractions you get for your infrastructure, how do you start abstracting away your application? So the first thing is developer fatigue and complexity, right? So how many times have you just heard something, just figure it out? And it's always the quintessential printer problem. And the holidays are coming up here, and for some reason, my parents still can't figure out how to connect their wireless printer to the network after a decade. And they think, hey, you're a software engineer, you can figure it out. No, I cannot. And so kind of going back through the same journey here is that, well, my background, similar to Andres, is that I've been doing Java development since the start of my career. And if you take a look at go back in the time machine when I started my career, building Java, right? And so as a Java developer, I might write some Java, I might write some JMS, and publish them to one of 3 target application platforms. And that was it. My purview was the feature, and someone else deployed, someone else packaged, and someone else operated the software, and that was it. Now, if we fast forward to today, I'm the same person I was years ago, but a little bit bigger and less hair in my head and all that stuff. But there's a lot more decisions that you as a software engineer have to make. And there's this concept of being a full lifecycle developer. A few firms made that popular. But not only in the Java language, there's more sheer. You just have to worry about the front end now, and with React and Node.js and all that stuff. But also, as part of the delivery methodology is that, well, I have to worry about how do I automate the build? How do I package the infrastructure? Are we going to use a container? Are we going to go native? Are we going to use, more often than not here at Shippa, we're deploying to Kubernetes. And so, I have to create a help chart. We have some configuration management with Kustomize. We have a Prometheus and a Fluentd stack for our observability, and we're going into AWS and GCP at the same time. So there's a lot more decisions that you have to make as a software engineer, right? And depending on how your firm is, you might be pulling in skills from multiple domains here. And it comes to this I don't know why my laptop is double tapping here, but it comes into this concept of Conway's law, right? So if you're unfamiliar with Conway's law states that your organizational communication will shape system design, right? And so how these teams communicate, well, this is how your system's going to be kind of architected and designed. So if you kind of look back at this eye chart here, it's all these icons that we have here. Like, who owns all of them? Who owns all of that? Oh, I think it's on an autoplay. Let me. Well, I'll have to get this kind of power through here. So, who keeps owning everything? So, is it a system engineer? The operational engineer owns all that. Is it a DevOps engineer who runs the development pipeline? Is it a developer? Are you the owner of all those particular facets? And also the more and more missing person, the rare unicorn. Are you still a release engineer? Is there still one on your team? Does your release engineer own everything, right? And so that's kind of like shaping your system design. And so because you have potentially 4 internal customers, if you're a platform engineer, there's this concept called developer experience. So what is developer experience? Hint, it's like user experience. Like, I'm going to give you a textbook definition of developer experience here. So what is developer experience? Well, developer experience is really measuring those overall interactions and feelings. So it's very, very similar to user experience, right? So if you're building a piece of software and you ever went through user experience testing or a whole bunch of user acceptance or testing, is that you're really trying to measure how the sentiment of somebody. And there's a couple of pillars, there's subjective and objective pillars you can have, but really the core definition of user experience, and swapping out user for software engineer, is that, well, how do you interact with the product or system of service, right? And so there's 3 perceptions that you're trying to measure. One is utility, does it provide that functionality? Ease of use, right? So are you able to a first-time user is able to learn that you're running through this particular piece of enterprise software? And then how efficient is it, right? Are they able to produce their tasks a little bit quicker? So the first one here is it's called usability. And so what is usability? And this really focuses on, imagine you were a first-time user of a platform, right? And so a lot of, especially in our industry, you could be tying dozens of pieces of software together. In the previous example, there was 3 CI Kubernetes-based CI tools that you potentially could have been using, right? And so, what is your experience if you were plop down your first day on the job? How can you measure someone's experience, or first day on the team, right? A lot of times, you're working on the same team your whole career, and so you want to make sure that a large part of, let's say, the time to value for teams is that how quickly can an engineer be ramped up on a new platform. And that's really this particular pillar is it usable? Can someone who has never touched it before, might they have some background knowledge, can they accomplish their goals, right? And so you can send out surveys, you can watch people, how they work. There's lots of ways to measure usability in your particular platform, right? And a lot of times with software engineering platforms, it can be a little bit complex because of the users. The next one is findability. So can a user, or in this case, software engineer, can they find the particular functionality that they're looking for, right? And so you might want to deploy something, or you might want to debug something, or you might want to make a particular change to something. How quickly can you find that piece of functionality, and B, it doesn't make common sense. Here's, it's it's a joke that this is actually, it's changing the volume from 1 to 100. You can make some really bad findability here, right? But also it's making sure that the user journey or the engineering journey is complete, right? So you might have user stories saying that engineers should be able to debug X number of systems, right? Are they able to complete their journey similar to someone in a consumer, like, hey, as a consumer land, can Robbie click and write a tweet, right? So it's the same vein. So the next part is credibility. So credibility in this example, like, where would you rather, as a consumer, where would you get your music? Would you get a virus from LimeWire, or would you rather use Spotify, which is pretty clean? But from a engineering or development platform experience, it's really about trust, right? That if you trust your particular platform to provide you that functionality. So one thing might be that trust might be, is the system even there, right? And so if you had to handwrite a particular paths yourself, or you know that, hey, we want to make sure that anytime someone wants to submit a build or someone wants to deploy, now I'm personifying a platform engineer, it's that our software is up, right? It's we all build systems before, and so if you have something that's very handwritten or very internal, that, hey, some of these non-functional requirements like HA or disaster recovery, they might not particularly be there, but really that makes your system more credible. I can trust Spotify or our build tools or SaaS tools to be there when we need them, versus, I'm not getting a virus, from LimeWire here. And let's talk about the march to application as code. So I'll kind of focus on the IAC and AAC stack. And if you're unfamiliar with what those are, don't worry, I'll explain them to you. So I'll kind of talk to the march as a core concept we're trying to push with Catch, our open source project here, is that it's this march towards application as code. So application as code is a layer of abstraction. I'm cheating. I gave you the end of the presentation a little bit early. But let's talk about a journey that most of us have been through. So kind of the first thing here is a decade ago that if I had to go get something done 10 years ago, this is the previous pre-Cloud Native days, is that most of my development environment was pretty static, or as a development manager myself, like most of the environment that we provisioned for the team was static. We had a static Jenkins instance, we had a static JBoss instance and artifact repository, and anytime that we needed to kind of leave our development area, is that we had to go talk to a system engineer saying, hey, can we get a couple more VMs? Can we get us some more? Can you add web server space for us? Can you modify the load balancer rules here so our routes will kind of go through? And this took time, right? They were pre-provisioned ahead of deployment time. How long did this take? It took weeks, right? Like at best, the VM took a couple weeks. Load balance, I don't know why the networking people took so long. It always took forever. And when we introduced more dynamic things like Kubernetes, it even got more complicated, but that's all been sorted out now. So, and also I guess the middleware folks are pretty snappy. They would take about a week, but and the thing is that 3 sets of people did this, right? So it wasn't one person who did this. If I need a VM, talk to the vSphere engineer. If I needed a load balancer change or DNS change, I'm talking to the networking engineer. Another node in the cluster, we're talking to the JBoss admin. Like, so there's multiple things that had to happen. But there's this set of automation that came up, maybe 5 or 6 years ago, that got really popular, is that infrastructure as code, or aka IAC, became very popular. So if you heard about tools like Puppet or Terraform, or even in Kubernetes land, like a very up and coming tool is a tool from Upbound called Crossplane, which is a Kubernetes native way of managing resources outside of Kubernetes, which it's very, very, it could be a different talk for a different day. But with IAC, if we took a look at, if we look at this particular time frame here, IAC really did 3 separate things pretty quickly. So what did infrastructure as code do, right? So if you remember these time frames that were there, IAC has benefits that, like anything you do with code, it's kind of three parts, right? So it's repeatable. So if you can call the same Terraform file, or if you're using CloudFormation with Amazon or Azure resource templates, you can keep going and going. Is that it's really repeatable. Your code's going to execute the same way every single time. So there's no human interpretation. And because it's repeatable, it's consistent, right? And so if it's being consistent, you can build your confidence that, okay, we can recreate things, especially in the cloud native way of doing things, it's you want to be able to recreate anytime, and so having that ability to be consistent, repeatable is important. And also it's callable, right? So you might have a continuous integration or continuous delivery stack really working on your development or developer pipelines, is that these tools are callable from other tools, so they can be orchestrated. So what really happened here is that the infrastructure time has got cut way down now. So, with the caveat that if infrastructure is available, you can probably use provision UVM in 10 minutes. If load balancer changes can be a couple minutes, and new app server node can be in 5 to 10 minutes. But there's kind of, as containerization and container orchestration begin to push forward, there's been a changing role of what I'm going to personify a few people here of what a software engineer and a platform engineer does. And so there's been a changing role. It's this concept of being a full lifecycle developer, right? And so it's becoming, especially certain parts of the United States here, is that this full lifecycle concept, companies like Netflix and Amazon made it popular a few years ago. And so it's this adage that if you wrote the service, you should know the service, right? And so I'm a little bit more of a pessimist. It's like, there should be some separation of duties, but it's if you wrote it, you run it, or if you wrote it, you know it. If you run it, if you write it, you operate it. Yeah, I always get the adage there a little bit incorrect, but that's basically it, right? So instead of the system engineer being there to provision your infrastructure, the changing job of system engineer is looking more like a platform engineer. They're making sure that your cluster, let's say if you're deploying to Kubernetes, that it has sufficient capacity and uptime, right? So they're operationalizing your Kubernetes cluster. So if you're on-prem, they're making sure that they're able to scale those clusters. If you're using a cloud vendor, they're making sure that you have access to the infrastructure that you need, and also tooling to onboard and also offboard your server or your applications onto the platform. Let there be Kubernetes. But kind of looking a little ahead, because we're at a cloud native meetup, is that if you take a look at what these challenges were, kind of pre-Kubernetes, there is this tool out there called Kubernetes, right? So the mighty Kubernetes. So Kubernetes really changed the game in a few ways, right? So here's a very easy deployment spec that I have here. But with Kubernetes, it's a great equalizer, right? So you write a declarative manifest. Kubernetes, to the best of its ability, will try to place to work and also meet those expectations that you have. So instead of several people saying, "Hey, you know what? I need one and one only replica of this particular pod at any time," Kubernetes will enforce that as a scheduler and a resource manager for you. And because Kubernetes is becoming more popular, there's a lot of items that are turning into asterisks as code. So there's code where there was not code before, right? And so in my engineering journey, I clearly remember having to write tickets in service now to get someone to add like entries for us, or routing entries, and now there's cloud native tools like service mesh, like Istio, is that there's codification representation of these particular routes. So there's no more, potentially I can write several Istio objects or manifests and whatnot, and I can get the routes myself as a software engineer. And so there's a lot of codification, this whole shift left notion, that there's skill sets that I used to have to not acquire that has to be applied to my day-to-day job as an engineer. And so what's missing here, right? And so if you take a look at kind of the space today, this is my sentiment, right? So I know that I wrote a compliant feature, right? Saying, hey, I passed code coverage tools. I got a B+ in SonarQube, which I don't. I usually get a C or D, but that's another story. So, and also as a software engineer, I'm not a kernel engineer, right? Like I'm here to write a feature. I'm not here to write kernel level, whatever Linux internals, or using eBPF, right? Like that's not part of my purview as developing a feature. But also I know certain things, and certain things don't change, right? Like, hey, I know that our application has to have traffic coming in, and I know that the application has to have traffic coming out. And as provocative as this might sound, usually as a software engineer, Kubernetes might be an implementation detail or something. Hey, my main concern is the feature here. And being a cloud native talk, this might be the sentiment of your internal customers, right? Saying, hey, we have this awesome infrastructure on Kubernetes, but hey, our feature did not change. The design spec of, let's say, how did I write the payment portal? It didn't change because we're going Kubernetes. The how we want to deploy it changed, but the core feature did not change. And so this leads to my buddy here, who's Vivek, his picture there on the right, the platform engineer. That now there's a bunch of tools to accomplish certain goals that a platform engineering team has to provide. Let's start from the top. If you need to deploy something, you might be using a GetOps tool like Argo or Flux. You might have this distributed networking stuff with Service Mesh. You might have Istio. You have to make sure that you're packaging things correctly with Helm. You might have a policy-based approach using something like OPA. You're scanning your images with Claire or some other particular scanning tool. You have to provide observability and time series stuff with Prometheus, and then you're managing all the clusters with Rancher, right? And so there's lots and lots of stuff that who owns that? Like, do I have to provide an OPA Rego rule to the platform engineer? Do I have to provide these particular Argo manifests to deploy? Do I have to package it in Helm? Like, who owns what? And this is where here at Shippa, we decided to come up with something a little bit different. And so talking about application as code, right? So like, how do we come up with a packaging that is exactly what you as a developer need? And so I'll start with this. And so the first thing that I like to say is that software is all about patterns, right? And so especially these two books were highly influential when I was in university and coming out of it. But really, here one on the left is Java, Gang of Four, the object-oriented book, and then also as I started getting into my career, like making two systems talk to each other. There's this book, really excellent, but I still have it. It's called EIPs, but really building these patterns together, right? So we're really picking little patterns and putting them together and aggregating them and building, at some low level, some functionality, right? Or we don't have to keep reinventing the wheel as a software engineer. And so there's this concept, looks like the autoplay stopped. So there's this, we came up with this concept called AAC, application as code, and kind of looking at kind of four pillars when you're defining an application, right? So it's one, it would be the policies, right? So this logical grouping of, hey, certain users have access to X, Y, and Z. I'll kind of give you the four pillars of our policy in a little bit. And actually, what is an application, right? So how do you define an application? Is it 20 Helm charts is your application? Is it, n number of images that you have? Is it, is it everything running in a pod? Is that an application, right? Like, what is a standard way for users to describe an application or end users or the business? And then also kind of abstracting away the infrastructure, right? So this is kind of the big one that, hey, why should my functionality, my application be different deploying on Kubernetes versus deploying on like an EC2 node, right? Like, hey, how I add two numbers together is not different in Kubernetes as a Python developer or a Java developer, and kind of abstracting that away and also providing you reporting and usage data on your application. So if you kind of take a look at some of the challenges, right, that personifying now, going outside of a developer, saying that if you're a platform engineer or if you're a DevOps engineer, how do you provide these particular pieces of functionality? And so it's one thing that, hey, our developers are able to iterate fast, perfect, but at the end of the day, these workloads have to go to production, right? And so this is all of your investment in your continuous delivery. But there's like 6 pillars here or that you're really trying to get right. You're saying, oh, you know what? How do we integrate this with our pipelines? Example, my biggest challenge that, and I've been using Kubernetes for several years now, is that I'm still not good at the networking side of things in Kubernetes. Like, hey, is this coming from a daemon? Is this coming from a worker node? Is this on the, do I have to go through the Kubernetes endpoint API to get to this, to get to that? How do I wire this together? My biggest outage of all times was a DNS, or was a networking outage in Kubernetes. And so that's kind of left me a little charred. But how do you provide all this, right? Like, how do you teach someone who's building a feature to be compliant with all of this? And what ends up happening is that you have all these particular YAMLs that you do have, right? So if who's writing your Istio YAML, right? Who's writing the rollout if you're using rollouts to deploy your application? Who's writing all of these particular things? And so what ends up happening is that if your platform engineering team doesn't take care of it for you, or they're not providing you like a really solid template or an archetype to say, hey, just fill in these blanks here, or using Go templating or whatever, it's a lot to wade through, right? Like it's a really big, I would say, deterrent for someone to start picking up this technology. It's like, oh wow, I just no more of me just pointing my image. It is a lot of non-functional things that I have to kind of build and package. And so with application as code, or AAC, we kind of package them in 4 separate ways for you. And so I'll kind of talk about them at a high level. What are the bare, I call them the bare necessities here when using our AAC solution or our open source project called Catch, is that there's kind of 4 things you quickly define in plain verbs, right? So it's not like, hey, we have to wire this very lengthy Istio YAML, or et cetera, et cetera. Is that in plain words, we can say, hey, Mr. and Mrs. Developer, traffic comes in here, traffic goes out here. And so basically auto wiring your ingress rules. Also, kind of when building a framework, this is kind of core to our AAC concept here, is that, hey, who has access to your application, and where can you pull particular application facets? So we're going from, a lot of times you're not going to the public internet, you're not going to Docker Hub to pull images, but let's say organizations like, hey, you're coming from our own GCR repository, or you're coming from our Artifactory internal repository that we have the images that are being curated. How are you actually going about scanning, your particular images here? Again, plain English or plain verbs. And also, hey, given, if you had to be a platform engineer, how do you provide limits? Like, you can't scale to infinity, right? So a lot of times you're building abstractions around Kubernetes to kind of limit people, saying, okay, we might limit the auto scaling groups or the resource limits, saying, Robbie, you can't have like 100 replica sets, even if the ASG determines that, or the autoscaler determines that we need to, as a platform engineer, you will be a detriment to everybody else's workload. If you do that, how do you kind of constrain and consume that? And then really defining what an application is, right? And so from a developer standpoint, they're really kind of like baking in like, hey, like what is an application? Is it your source code? Are you using a build pack? Is it an image, right? Are you having something ready built? Who has access to your application? And also, hey, where's the DNS information for that application, right? Like, is it a service? In Kubernetes, is it a load balancer, is it a node port? Like, how are you getting access to that application? And really clearly defining what that is. And so kind of talking about, hey, application as code is here. Unfortunately, I think I would have actually had kind of an example to kind of show you. I didn't have that this morning for you. But one thing I do want to kind of iterate is that, we're up for CNCF sandbox catch. So we submitted to CNCF. We're still waiting for approval or not, if our project is there, but really excited, start getting the word out there about application auto placed again. So really excited to start talking about AAC. Be on the lookout in the CNCF for catch. It's our way of abstracting what an application is and certain facets of how you get that application into production. That was all that I had for my part of the my part of the presentation. If you want to learn more, we have created several demos out there for I'm between you and lunch currently. So Shippa.io, hit me up on Twitter at RobbieLock. I'm just our last name Shippa.io, and feel free to interact with us in Slack or the CNCF Slack. So thank you so much this afternoon for your time.
Thank you very much, Robbie. It's a pleasure. It's great to see all of that work. I would like to ask Marcos whether we have any questions coming from the audience.
Yeah, actually, again, another very hot presentation on the social media. Many comments on Twitter. So congratulations, Ravi, and thank you again for passing by.
Sure.
A question that came from the community. The companies have different levels of maturity, right? and with that level of maturity, they can reach different, let's say, stages or levels. So from your point of view, for a company to reach this level of application as code, as you are mentioning, which signals we can see that could foresee the companies reaching that level?
Yeah, it's certainly, if I got the question, or just, I mean, it's more of a conversation. I think I wish I would talk that person to person. Like it takes a long time, right? Like I'm a little bit of a pessimist that technology is very cyclical, and so that area of maturity is like it's I think it's very attainable, right? Like the complexities that were off of Kubernetes didn't go away because Kubernetes came about, right? Like it's the old computer science adage, complexity is like an abacus. You only go left to right, you don't remove it. And so it's really, it's really focusing on your internal customers, right? It's, if you want to get to this AAC type of model, without an open source, like a project like Catch behind it, like what we've seen is a lot of people are building that, right? So we've had, specifically talking for Shippa and Catch here, is that I had the opportunity to talk to a lot of developer tooling organizations. And so it's a lot of things that people are building, right? So it's kind of the next gap. Like, how do we train somebody who's unfamiliar with the tooling? Like, it could be a number of cloud native tools. How do we get them to be productive? And so it certainly is a journey. There's lots of abstractions being built, and there's a couple of great projects. One of them, pay homage to Kubevela, also that's in the CNCF. And so they're trying to do a somewhat similar way of abstracting away Kubernetes resources. So I don't know if that was a direct answer.
I think it's a very good answer, actually. Thank you very much, Ravi. Angel, I would say at the minute, no more questions. Back to you. I cannot hear you, Angel. You are not mute. There you are.
Can you hear me now?
Yeah.
Okay. Troubles with the sound until the end. All right. There are no more questions here in the audience, here in the room. So I guess we could wrap up here. It's been a pleasure to be with all of you. I would like to thank again Abel for giving us the opportunity to stay here with them today, and thank everybody that came along to see us here on our first on-site event from Cloud Native Asturias. We will have more events like this in the future, so stay tuned. And thank you very much. Thank you very much, everybody. We'll see us in the next event. Thanks a lot.
Thank you, guys. So yes, a couple of words. Thank you again to everybody, all the speakers, Abel, Jose Redondo, Andres, and also Ravi, that is going out now. So thank you, everybody, for everything. And actually, this was a great success for this event. I can tell you in the social media, this is really, really hot. So thank you, everybody, and see you next time.
Thank you. Bye-bye.